right, for problem 4, we're looking at factoring a difference of two squares. Now, before we do this, we want to look to see when is a term in the form ax squared a perfect square. Well, in order for the entire term to be a perfect square, that a has to be the perfect square. The a is the thing that has to be the perfect square, because you're always going to have a variable squared there, but you have to have the coefficient. The coefficient has to be a perfect square. So, for example, 16x squared, that's a perfect square, because 16, square root of 16 is 4. But 17x squared is not a perfect square, because the 17 is not a perfect square. So let's take a look at factoring the difference of two squares when we have a coefficient in front of our first term. Okay? So here we have 25d squared. Now, when we're looking for our a term, we have 25d squared, and of course we want to find the square root of that. So that's going to be 5d. So my a is 5d. My b is equal to 64. And of course we're going to find the square root of that, and the square root of 64 is 8. So the binomials that we're going to write are going to be in the form a plus b times a minus b, because again, there's no middle term here, so this is the format. So we've got 5d plus 8, and we have 5d minus 8. And there's your final answer. There you go. I know you guys are loving it, because it's so easy.